right, we're going to cover section 8.1, scientific notation, with chapter 5 because it deals with negative exponents. So I like to put it with the sections that deal with negative exponents when we're learning about them because it gives us some practice with that. So let's talk about what scientific notation is. With our base 10 number system, 10 to a whole number power is the number 1 with that many zeros after the 1. So let's look at some examples, make sure we understand that. So for example, 10 cubed says it would be a number 1 with 3 zeros because A is whatever the exponent is. And 10 cubed is 1,000. Right? Another one that we probably know is 10 squared would be a 1 with 2 zeros behind it. But this works for no matter what that exponent is for any whole number that's greater than 0. So 10 to the, let's just say 7th, would be a 1 with 7 zeros. And usually what I would do is just write out the 7 zeros and then figure out what that number is by counting backwards this way. Every 3 gets a comma, so this is 10 million. Similarly, when there's a negative exponent, remember negative exponents make fractions, so in this case we would start having some decimals. So instead of adding zeros at the end, we're putting decimal places before the 1. So for example, 10 to the negative 1, the definition of a negative exponent would be that that's 1 over 10, and 1/10 is 0.1. So A is 1 decimal place. For 10 to the negative 1, we have 1 decimal place. 10 to the negative 2, it'd be 1 over 10 squared, or 1 over 100, which is 0.01. So for an exponent of negative 2, we have 2 decimal places. And it would, keep going, of course. If we do 10 to the negative 7th, it'd be 7 decimal places. Now be careful though, because that's not the same as 7 zeros, I guess, unless you write that 0 in front of the decimal. It's really 7 decimal places with that 1. So if you count the 0 in front of the decimal, then it's 7 zeros, but otherwise it's 6 zeros after the decimal place. So now that we have that settled of what positive and negative exponents on 10 specifically do, where we can use scientific notation. So here's sort of a summary of what these powers of 10 look like, both as exponents and as decimals. Scientific notation uses these powers of 10 to write any number. So we're always going to have some number in front, and then we're going to multiply that number by 10 to a power. And that exponent now could be positive or negative. C is any real number, but it's very specific in that we want C between 1 and 10. So it's always going to be some digit point something else, right? And it could just be 0.0, it could be a lot of decimals, but we want 1 digit before the decimal point. Now, there's actually a movement in the scientific community to change that and to not be so limited, but that's not what we're debating. We are going to do it the traditional scientific method way, where we have 1 digit before the decimal point and then times 10 to a power. Now this exponent on A, if A is positive, that will move the decimal to the right. So positive exponents move right, and negative exponents will move the decimal to the left. Exponents to the left. Just like up here, positive exponents on 10 made the number bigger. In other words, that's sort of like moving the decimal to the right. We added zeros. But negative exponents made the number smaller, so it ends up moving the decimal to the left. So let's put this all together and see some examples of this. So when this is used and why it gets used in science is because different fields of science deal with sometimes huge numbers and sometimes microscopic, tiny numbers, right? So it's really useful for huge numbers. Like in this case, remember this exponent on 10 is like the number of zeros. So we would move this decimal point 24 places and it would be huge. We wouldn't want to write that out. I certainly wouldn't want to sit and count 24, or in this case, if we move it 1, 2, 3 decimals, it'd be 21 zeros. I don't want to sit and count 21 zeros and miscount and maybe only think there's 19 of them. So this tells me how big the number is without me having to sit and count zeros. Same with this -8 gives us an idea of how tiny that number is, because this would be 8 decimal places, right? And so, in other words, we would move this decimal point to the left 8 spots. All right, so now that we get the idea, let's do some concrete examples, make sure this makes sense. So this is 1,234. In scientific notation, remember we just want one number in front of the decimal point, or one digit before the decimal. So it's always a single digit that's non-zero. Then we need to figure out what exponent on 10 do we need to multiply by to make 1,234. In other words, how many decimal places do I need to move to make it go back to 1,000? And in this case, it'd be 3 decimal places. And this sort of makes sense because 10 cubed is 1,000. So we're multiplying this number by 1,000 to make it a number in the thousands. Let's try some more of these. So part B, first step is to write it with a single digit in front of the decimal. Now anything that's zeros I don't have to write, because remember it's 10 to the exponent that's going to add those zeros in there. So need that single digit before the decimal. Can't be 0, it has to be something not 0. Times 10, and in this case, maybe I'll draw it up here this time. So here's where I'm putting the decimal after the 1. I would need to move that decimal 1, 2, 3, 4, 5, 6, 7 places to get it back where we started. So that means I'm multiplying 1 and 25 thousandths times 10 to the 7th. And that makes sense because 10 to the 7th is 10 million, which is close to what we started with. Let's try part C. So now we're getting smaller, so we're going to need negative exponents for small numbers and decimals. But first I start by just writing this with a single digit before the decimal point. So times 10. And I know the exponent's going to be negative because we have a tiny decimal here. So let's put the decimal point where I'm putting it here and figure out how many spaces back we need to go to get back to the beginning. So it looks like we need to go back 1, 2, 3, 4 spaces, so that's 10 to the -4th power. Last one, so we're going to start with 7.325, or 7 and 325 thousandths, times 10. And again, I know it's going to be a negative exponent because this is a decimal. It's a small number. Small negative exponents make fractions or smaller numbers, where positive exponents get bigger. All right, so here's where we're putting the decimal. So it's just 2 decimal places off. So this would be 10 to the -2nd power. Let's go the other direction, and hopefully this will keep making more and more sense as we go along, especially if this is new to you. So this is, now we're starting with scientific notation, and we want to convert into a standard decimal notation. All right, first one, I see positive exponent. That means it's going to get larger. So we're going to need to move the decimal point 9 spaces to the right. So this moves 9 right because it's positive. All right, so instead of 9.12, I need to move the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or, you know, if you're trying to be more sophisticated with this, I need to move the decimal point 2 places to get it past the 12, and then there's going to be 7 zeros left. So to make 9 spaces, it's 1, 2, and then 7 zeros. So my number will be 912 with 7 zeros. And then we should figure out where the commas go. Oops, sorry, I knocked my phone. All right, let's figure out these commas. So I'm going to count 3 from the right. 1, 2, 3, 1, 2, 3, 1, 2, 3. So this is 9,120,000,000, and then that's it because the rest are zeros. All right, let's try this one. Again, positive means it's getting bigger, means it's moving to the right. So we're going to move the decimal 4 to the right. So I start with 3.05 or 3 5/500ths. And I'm going to move the decimal 1, 2, 3, 4. And fill in with zeros. So my final answer, after I write it, is 30,500. Make sure that's a comma, not a decimal point. The commas just help for pronouncing the numbers especially. All right, let's do a couple where we're moving the decimal point to the left. So negative exponents move the decimal to the left. So I'm going to start with 8.25, but then this decimal point is moving back 1, 2, 3 spaces. So as a decimal, this is going to be 0.00825. Or you could do that trick where for a negative, the number of zeros would match as long as you count that 0 in front. So 3 zeros, counting that one. Let's move the decimal 6 to the left. So I'm starting with 1.8301. And we're going to take this decimal point and move it back 1, 2, 3, 4, 5, 6. And fill in with zeros. Or you can view it as 0 point, and then there'd be 5 zeros, 18301.